is 631. It's titled Solving Systems by Elimination. We're going to answer the question, how can I solve without substituting? So Jeanette is trying to find the intersection point of these two lines. Here's our two equations. That's called a what? A system. When you have two or more equations, it's called a system. Say system. Okay. She had decided to use substitution to find the point of intersection. Her plan is to solve the first equation for y and then to substitute the result into the second equation. Use Jeanette's idea to solve this system. So the first way we're going to do it is by substitution, which is how we've been doing it for the past couple days. All right, so we're going to take that first equation, which is 2x plus 3y equals negative 2. We're going to subtract the 2x from both sides. And then we're going to divide all of 3 terms by 3. Okay? 3 goes into 3y, y times. I'm going to leave the negative 2/3 as a fraction, and I'm going to leave the negative 2/3 as a fraction. Okay? That's the first equation solved for y. I'm going to substitute everything that y is equal to into the second equation. So when you plug it in, you get 5x minus 3, and then instead of writing y, you write negative 2/3 x minus 2/3. Put the whole thing in parentheses so you remember to distribute. Okay? Then write the equals 16. Okay? Now we're going to distribute. So you're going to draw your little distributing rainbows here. You're going to repeat the 5x. And then negative 3 times negative 2/3 x, the 3's cancel, and you have positive 2x. Because a negative times a negative is a positive. Good. All right, then we're going to multiply negative 3 times negative 2/3. Again, it comes out positive. And then you look for like terms. Are there any like terms there? Yeah, what are the like terms? The 5x and the 2x combine to get your 7x, and subtract 2 from both sides, so you get 7x equals 14. What is the inverse operation of multiplying by 7? So you're going to divide both sides by 7, and 7 goes into 14 twice, 2 times. Okay? Bless you. Now we're going to solve for y. So we're going to take that 2, and we're going to plug it into either of these first 2 equations. I picked the first one, but you can pick the second one and see if you get the same answer. So we're going to have 2 times 2 plus the 3y equals negative 2. 2 times 2 is 4. So we subtract 4 from both sides. And then the inverse operation of multiplying by 3 is dividing by 3. And we end up with y equals negative 2. So our answer is 2, negative 2. Okay? We always write which variable first? X, because it comes first alphabetically, right? All right. Jumping down to question 80. I do not like the way it's worded, so I'm going to have you guys skip parts A and B. You can cross it off if you want to, and we're going to jump all the way down to C as in cat. Shrink it just a tad. Load it. All right, so part C down at the bottom says we're going to use the elimination method to solve the system of equations below for x and y. And then we're going to check our solution. So the 2 equations down on part C are 2x minus y equals negative 2 and negative 2x plus 3y equals 10. Okay? So we just read the math notes box on page 20, and the first thing it tells us to do is to make sure everything is lined up with our like terms. We have our x's lined up, our y's lined up, our equal sign lined up, and our numeric parts lined up. Okay? Then you see if you have opposite coefficients on any of your variables. And because this is one of your first elimination problems, the answer is yes, you do. Look on the x term. You have 2x and you have negative 2x. If we combine 2x and negative 2x, what do we get? 0. No, we don't even get x. We get 0 because they're opposites. Okay? So you don't even need to write 0. You just leave a blank. Okay? Now we're going to combine our y terms. What is negative y plus 3y? So you're going to write 2y. And then you're going to combine what's on the right side of the equal sign. So you have negative 2 plus 10, which is 8. Okay? And what is the inverse operation of multiplying by 2? So we're going to divide both sides by 2. How many times does 2 go into 8? 4 times. So we've solved for our first variable already. Okay? Now we're going to take that 4, and we're going to plug it back into either of these first two equations. Looks like I picked the first one. Okay, so I'm going to say 2x minus 4, plugging in that 4 instead of y, equals negative 2. Then I'm going to add 4 to both sides. Then I'm going to have 2x equals 2, divide both sides by 2, and so x is equal to 1. All right? Then I'm going to write my ordered pair as my final answer. So my ordered pair is 1, 4. Make sure you put the x variable first, then the y variable. All right? Turn over to page 19. This will be at the top in just a second, if you're still writing. All right, question 81. Let me show a little bit more. All right. Pat was in a fishing competition at Lake Pisces. He caught some bass and some trout. So what variables do you think they want us to use? B and T, bass, trout, okay? Each bass weighs 3 pounds, and each trout weighs 1 pound. Pat caught a total of 30 pounds of fish. That's going to be our first equation. He got 5 points in the competition for each bass, but since trout are endangered in Lake Pisces, he lost 1 point, bless you, for each trout. Pat scored a total of 42 points. Okay, so the first thing they want us to do is write a system of equations representing the information in this problem. So the first equation has to do with the weight of the fish, right? So the bass weighed 3, so we say 3b. The trout weighed 1, so we say 1t. If you want to write a 1 in front of that t, you can. And together, they were 30 pounds. All right? The second equation has to do with the points that he earns for each fish. So he gets 5 points for bass, but on trout, what happens? He loses points. So I'm going to say minus 1t for each trout, and he gets a total of 42 points. So these are our two equations. All right, part B. Explain why this system is a good candidate for the elimination method. All right, why would this be good for elimination? Dennis.
There's 2 different variables in this equation.
Yeah, both of them have a B and a T. Anybody else see another reason? Lee. Yeah, on the T's, one of them's positive and one of them's negative. So they're opposites, okay? This is called the elimination method. We want to get rid of something. So we're going to get rid of the T's, right? So the variable T is ready to be eliminated. That variable T is already ready to be eliminated. We don't have to multiply by anything. Okay? Part C says, solve the system to find out how many bass and trout Pat caught. Be sure to record your work and check your solution. So we're going to take our 2 equations, 3b plus t equals 30, 5b minus t equals 42. The t's are opposite. They're going to eliminate. What is 3b plus 5b? 8b. Okay, and then on the right we have 30 plus 42, which is 72. What is the inverse operation of multiplying by 8? Okay, so we're going to divide both sides to 8. How many times does 8 go into 72? 9. So that means we have b equals 9. That's our bass, right? Now we need to figure out how many trout. So we're going to take that 9 and plug it back into either of the two original equations. I picked the first one. So I said 3 times 9 plus the t equals 30. 3 times 9 is 27. I ran out of room, so I had to come up here. I subtract 27 from both sides, and I got t equals 3, and that's my trout, right? So I've got 9 bass and 3 trout. Okay. Question 82. Annie was going to use the elimination method. She was ready to add the same value to both sides of the equation to eliminate the x term when she noticed a problem. Both x terms are positive. Okay? So here's our two equations. We have 2x plus 7y equals 13 and 2x plus 3y equals 5. So everything's lined up properly, but when you go to eliminate, you have the same coefficients. When you have the same coefficients, there's an easy solution. Does anybody know what it is? Oh, lots of people. What do you think it is, Dustin?
Turn one of the equations
Negative, okay? So that's what we're going to do with your team. Figure out something you could do that would allow you to add the value of the second equation to the first equation and eliminate the x terms. Once you have figured out a method, solve the system, okay? So we're going to multiply the first equation by -1. Could you multiply the second equation by -1?
Yes.
Sure. You pick whichever one you like. I'm going to do the first one. All right? So 2x times -1 is -2x. 7y times -1 is -7y. And 13 times -1 is -13. So basically, everything switched signs. All three parts switch signs, okay? I don't need to do anything to the second equation. I just write it down, okay? Make sure I'm still lined up, okay? Now that x variable is going to eliminate because they're opposites, and that leaves us with just our y's and our numeric term. What is -7y plus 3y? -4y. And what is -13 plus 5? I got -4y equals -8. What is the inverse operation of multiplying by -4? So we're going to divide both sides by -4. It goes in there twice. Okay? Now I'm going to take that 2 and plug it back into either of the two original equations up here. I picked the first one. So I'm going to say 2x plus 7 times 2 equals 13. 7 times 2 is 14. So I'm going to subtract 14 from both sides. That leaves me with 2x equals -1. So I divide by 2. And my final answer is -1/2. Since this one's an x and a y, I can write my answer as an ordered pair. So I write my x value first and my y value second. All right.